A very good morning and welcome to all of you for the first of the webinar organized by Daily Association of Mathematics Teacher DAMT. Initially, I would request Mr. Ajay Marwa to introduce and give you brief introduction to DAMT. Over to you, Ajay sir.
Thank you, Amit sir. Hello and good morning to everybody. So here is a brief introduction of Delhi Association of Mathematics Teachers, that is DAMT. It's a venerable institution dedicated to the advancement of mathematics education, founded on May 28, 1970. It's been 54 years since then, when many of us were in our childhood. DAMT was established by a group of visionary educators, including Shri J.M. Sharma, Professor Mohan Lal, Shri S.N. Chibbat, and Shri J.C. Nijhawan. It was officially registered under the Society Registration Act of 1860, marking the beginning of a significant journey in the field of mathematics teaching. In its early years, DAMT's activities were driven by an esteemed editorial board composed of late Shri J.N. Kapoor, late Shri G.D. Dhal, Mrs. K. Alamelu, Shri S.N. Chibbat, Shri M.K. Singhal, Shri R.C. Gupta, Shri V. Session, and Shri D.K. Sinha. These pioneers laid a strong foundation promoting the professional growth and development of mathematics teachers in Delhi and beyond. Recently, DAMT has been revitalized with fresh enthusiasm under the leadership and guidance of the pioneers, patron Shri Mohan Lalji, advisor Shri VP Guptaji, President Shri SN Chibbarji, Vice President Shri JC Nijavanji, Secretary Mrs. Anita Sharma, Joint Secretary Dr. RP Singh, Treasurer Mrs. Simi Bhatia, from the editorial board Mrs. Roman Dhawan, Dr. Amit Bajaj, Mr. Sanjay Kumar Sinha, and social media manager Mr. Rohit Upadhyay, and other esteemed members. The primary and objectives the primary aims and objectives of DAMT are multifaceted and ambitious. Number one, professional growth. To create a robust forum for mathematics teachers in Delhi and to extend its reach to an all India level by enrolling teachers from across the country. Number two, information dissemination. To provide valuable information of professional interest to its members through newsletters, journals, and other publications. Number three, resource preparation. To prepare monographs on relevant school mathematics topics and to collaborate in conducting mathematics Olympiad activities with other agencies. Number four, educational exchange. To facilitate the exchange of ideas and views on mathematics education through symposia, conferences, study circles, meetings, seminars, and exhibitions. Number five, curriculum development to assist agencies in creating a model curriculum that caters to children of various aptitudes. Number six, beyond curriculum activities to extend mathematical activities beyond the school curriculum, fostering a deeper engagement with the subject. Number seven, Mathematics Academy to establish an academy that offers consultancy services in mathematics education at primary, secondary, and senior secondary levels. Number eight, professional interests to promote the professional interests of its members by distributing relevant literature and books on general and specific mathematics topics. So DAMT continues to be a beacon for mathematics teacher, fostering an environment of continuous learning, collaboration, and professional excellence. So thank you to all. Over to Amit sir.
Yeah, thank you so much, sir. That was a brief introduction. So this is the first of the webinar organized by DAMT. That's the reason we are taking just 5 to 10 minutes initial in the beginning. From the future webinars, we'll be just starting with that. Okay, so I'm sure a lot of you already have joined DAMT, but still, if not, you are requested to kindly join in. And there is a registration form that will be shared in the chat. So kindly check at the chat box. We'll be sharing all the resources, all the links, whichever are required. And please do join. And please note the membership, as Ajay sir already mentioned, it is not only for the Delhi teachers. It is open for all the teachers who belong to any state in India or even abroad. And that's also for the math teachers, educators, principals, trainers, researchers, all those having the passion for the subject. So benefits, as already sir has mentioned, I'll skip on this. And yes, we are having a volunteer initiative for the 5 main key domains. Almost 100 plus educators have already filled in that form. Even still, if you are interested, we'll be sharing the link again in the chat box. You can go through the same and do the needful. We come up with the idea of our first of our e-newsletter, that's a Ganit Odyssey. And we are looking, and that's basically the Ganit Odyssey, and showing it to you. That's a physical form of our magazine, Ganit Odyssey. Yeah. And we are looking forward to receive the articles from your side. The guidelines are being already set. That's being shared on our website also. And we are circulating in various social media and the WhatsApp group wherever we are connected. So we are looking forward for innovative ideas from you. Though we have set the word limit is set to be, say, 1000, but yes, it can be only 200 word, one pager write up only. That is also acceptable. But yes, this is a time of AI. So please do take care of this important part, plagiarism. So we'll be checking all the documents being submitted by you through the professional softwares. So please do needful accordingly. And yes, we have started with the idea of Brainy Bites. That's our maths challenge. And that is again circulated through our social media. There are certain guidelines. You can check that out. We'll be sharing the links and resources in the chat very soon. And there are a lot of media through which you can get connected with DAMT. That will be shared with you. Any question, any doubt, you can directly connect to any of the executive member, or you can write us email. So we'll be responding back to you for sure. Yeah, so next, the main agenda is about the session for the day. That is the divisibility rules for the prime numbers using the Indian knowledge system. For that, we have actually Roman ma'am for this webinar. But before I invite her to start with the session, I would quickly like to showcase that the teachers not only from Delhi. Can you see this? About 23% registrations are from Delhi, but we have the registration from all over India, and not all from India. From foreign schools also we have the registrations. But as I already have mentioned, since in a number of schools this is a working day, and we kept the webinar in the morning. I will try to keep now the webinars in the evening time only, which is comfortable to most of the teachers, so that you all can join. And why the response? Because this is important for Roman ma'am also to know that out of the 866 responses, and this is not being updated, 15-20 more registrations done later on also once I completed with this presentation. We have the primary teachers about 21% joining. 6 to 8 we have around 55-56%. 11th to 12th we have around 37% teachers who have registered. And we do also have the undergraduate and certain professionals, those who are actually not into a teaching profession, but they have the passion for mathematics. So welcome once again, all the passionate mathematics educator. And yes, if you are looking forward to take the webinars on behalf of DAMT, please do connect with us. Few of you already mentioned, we'll be sharing the feedback with you. So all the details will be mentioned in that. Also, there's a simple decorum and protocol which we expect to follow. So please select a very quiet location which is free from the distraction. Your microphone will be muted throughout the presentation. Kindly respond in the chat box when required. Sometimes we will open and disable the chat box also. But yes, when Roman ma'am wants, we will definitely open the chat box to hear from you at the same time. And please reserve your questions for the Q&A segment. At the end of the webinar, we'll be handling your all the questions. And yes, when you come across something new, please do not hesitate to your support, thumbs up or the clapping or any emojis you find in the chat. Now coming to the participation certificate, because most of you, of course, we are looking forward to the same. And the link for the webinar participation certificate will be shared in the chat box. Do remember to fill your all the details correctly, and this will be sent via email, right? And also it will be accessible to a different link. This is one Google Sheet. We'll be sharing the link with you. Very unique thing you need to remember. There is a unique code you are required to enter in this feedback form. If you do not enter the correct feedback for that unique code, you won't be able to proceed further and you will won't be able to get your certificate. So watch carefully, listen carefully. We will be announcing that code 2-3 times, or we'll be writing in the chat box. So your attention is essentially required. And please do not later on say that we cannot, we are not aware of that unique code, or there was a network issue. We will not be sort out anything. So with this, and this is a kind of a certificate which you will be getting. So your name will be mentioned and your school name will be also written. So please fill in your email and these details very carefully. Any spelling mistake, any correction, that will not be taken care of. I hope you all can understand that. And the unique code for attending today's webinar is 6174. That's a famous carburetor number. So please note it down. Those who have joined, I will be sharing once again later on. So finally coming to our presentation, it's almost 14-15 minutes, and Roman ma'am, you have about 1 hour, 10 minutes, and then we'll be taking care of the Q&A. So Roman ma'am is a session expert for today. She's a former head of department of mathematics from Kulachi Hansraj Model School, Ashok Vihar. She's also the editor for Daily Association of Mathematics Teacher. She's a very dynamic mathematics passionate educator. I think into the profession for more than, she served the profession for more than 30-35 years. So we would love to get from your insight the knowledge in this particular session. So welcome Roman ma'am, over to you. You can share your screen, ma'am.
Yeah. Good morning to all.
Yes, good morning, ma'am. You are audible. Your screen is visible. You are good to go.
Thank you. Thank you so much, Amit ji, and for introducing and saying such good words about me. Uh, Thank you to DMT to give me this chance to begin with a very fruitful activity, which will be helpful, I think, and it is required by the today's educators. Uh, the need is really much for this particular topic as well. Divisibility rules, as I'm saying. Why is divisibility important? Now, today's student, I have seen the kind of teachers, the percentage of teachers that I have in front of me today. So in the school, the child has become so aware that they want to know that, okay, maths पढ़ रहे हैं हम, तो इसमें we have profit and loss and we have such things, which are useful. So they just understand the use of only commercial mathematics. Other than that, many a times even the parents as well as the students are not able to follow that why things are required. Now divisibility rules, no doubt it helps you to compare the costs and prices of things by comparing per head how much is cost. That's the simplest application that a primary teacher can tell its students to understand it. But if we talk of the middle school level and the secondary level, I think that it's worthwhile telling the students that divisibility, division, and these operations, they are not simple operations. They are used in the further study of number theory. Not only that, they are used in computer programming. They make programs out of this. And obviously, if they are making programs, there's certain need about it. And it is very much in use in cryptography. It is used in cost and sales analysis strategies. So divisibility has lot of real life applications as well as for research basis. Now, the regular divisibility rules that we do in our school, that limits a child for only till the number theory and so on. So when we talk of divisibility, say check the divisibility by 41 or say by 37 or say by um, say 29 and so on. Our student and our teachers both are not equipped with any other method other than division. So they carry out the long division, and in the long division they are finding the quotient and other things. Now here, Bharatiya Ganit, or I would say Indian knowledge systems, it provides us with a few techniques, and these techniques will help us to check the divisibility in a very fast manner. Now let's see how they will help us. And everybody now, of course, if you have heard of Vedic mathematics, you know that Swami Bharti Krishna Tirth Ji, who was the Shankaracharya of Puri, he had written books, rather notes, and out of them only one book got printed. Um, and he was quite a knowledgeable person. He actually worked as a principal, and he was an professor of mathematics before becoming the principal of that college in West Bengal. Anyways, I'll not go to those details, but these rules and these they equip a person with, within minutes we can check up the divisibility rules. And let's see how today's journey I will try as much as possible, because I thought that 1.5 hours means I may get 1 hour 20 minutes or maybe a little more. But as the Vedic mathematics, I have to introduce a few definitions, just a few, 2, 3 of them. And as mathematics teachers, I know that you'll be very sure, I'm sure that you'll be able to pick them up very fast. So let's go on to the journey. And if we get time, we can extend it sometime further also. So the divisibility rules that I'll be taking up. And here, yes, Amit sir said that I have 35 years of experience of teaching, but that is not only experience of teaching, but also searching alternate methods of doing mathematics other than modern mathematics. So I have been a searcher, and thankfully I have been able to train myself in one of them much more than the others, and I am here in front of you. So here, some basic definitions in Bharatiya Ganit. I hope this is visible to everybody.
Yes, ma'am.
Okay. Thank you. Now the first definition is base and subbase. So if we have a number, say 7, then the base for this will be 10. How do we say 10? That is one digit number. So I place a 0, and then with that I place a 1, and I get the, so eventually it is the next you can say number which is ending with 0 or a multiple of 10. Anyways, we can think of it. Let me talk of, say, 27. Now 27, there are 2 digits, so 2 zeros and 1. So 100 becomes the base. But if I count 27 plus 3, it becomes 30. 30 will be called as the sub base for 27. Now 30 is the higher sub base, right? And many a times in Vedic mathematics, we need the lower base also. So 27, if I subtract 7, I'll get the 20. So that also becomes a subbase. So if I say 3, 9, 2, 1, now the base will become, base will become, I'll just, one and 4 digits here. So 4 zeros, 10,000 becomes the base. And if I want the sub base would become, in this case, because it is say 3921. So you can say that 4,000 is one of the base sub bases, or you can also say that 3920 is one of the bases. So you can have many bases as per your requirement, right? So we may have things like this. So let's come to the next. I hope it is clear because it is very simple. Complement or nihilum. Now, complement or nihilum of a number. So if we have, say I have 8, then what should I add to 8 to get its base? The base is 10, and so for 8 the complement will become 2, or rather I would say 2 and 8 are complement of each other, or they are nihilum of each other. Let me take up another one. 34. Now for 34 it will become 66, because 66 and 34, they will become complement of each other. Same way you can find out for, say 129. Now if I want to find out, it will become here 871 becomes the complement, and the complement of 871 is 129. Now in order to find out the complement very fast, here is the number 3. It is a sutra which says Nikhilam Nav Tascharmam Dashataha. So if Hindi words or Sanskrit words are difficult, we have the English version. It says all from 9, last from 10. Now here the last is the rightmost digit, or you can say the units place digit, right? So when it was written in the scriptures, they did not say anything about, they did not name it as units or tens or something like that, but they were given specific words of Sanskrit. And so ending word was used. And so here charmam ka meaning hota hai ending. So basically it was like this. So if you notice 8 here, so what have I done? It says all from 9, last from 10. So I just have one digit. So from 10, I have subtracted it. Very simple. But for 34, you check up. What have I done? I have taken this 3. I have taken it out from 9, subtracted, got my 6. And if I take 4, it is the last one. So it has been subtracted from 10. And so I get 6. Exactly in the same manner here, 1 and 2 will be separately subtracted from 9. So 9 minus 1 gives me 8. 9 minus 2 gives me 7. And 10 minus 9 gives me 1. So just in very quickly, we are able to write down the complement of any number, however big it is. For example, if I take up 5, 6, 3, 1, 9, 0. Now here, what will it become? The last one from 10. So it has to be 0 only. We don't say anything about it. Now the rest of them, that shifts from here, right? So it becomes 1. क्योंकि 0 है तो 0 के साथ कोई शिफ्टिंग नहीं होगी, और यहाँ 9 का कॉम्प्लीमेंट लास्ट फ्रॉम 10 लेना है, because 0 will not be taken into consideration. And here I'll get 9 minus 1, 8, 9 minus 3, 6, 9 minus 6, this, 9 minus 5, 4. So these two are complement of each other. So it makes the thing, the sutra makes the calculation much faster. Fourth is digital root or Mulank, or we also call it Yog Mulank. And then the subtractive digital root, Vyog Mulank. So I'll just simply take up one or two examples in this. Digital root, most of us are clear. It is the sum of the digits of a number. So if I have 2, 3, 1, so the digital root becomes 3 plus 2, 5, and 1, 6. So it's as simple as that. You add up all of them. And if it is more than, say, 10, if it becomes, say, 4, 8, 2, 3. Now, 8 and 2, 10, and 17. So the digital root, it takes the logic. It becomes first 17, and then you add these two, and you get 8. So keep on adding the digits till you get a 1-digit number, and that becomes your digital root or Mulank, right? Now the subtractive digital root or Vyog, as it says. So Vyog का मतलब है यहाँ पे subtraction. So if I talk of the same number 4, 8, 2, 3, we take this number and this number, and we take the total of 4 and 2, that is 6, and we take the total of 8 and 3, and that is 11. So 6 minus 11 makes it minus 5. So minus 5 becomes the Vyog Mulank, and many a times we don't need the symbol also. So just the difference 5 becomes the Mulank, right? So if you remember, I think for 11, the divisibility by 11, we need this thing. So I'm not going into detail of that because it will take time. Now the fifth one is vinculam or mixed numbers. We call them as Mishrank also. Again, I will go to the detail of this fifth one only if the time permits me later on. So I will not burden you with that right now at the moment. Well-known divisibility rules. A number is divisible by 2. Now, most of these things are known to us and we are teaching the students in the class. So here I have the examples. So 8, 26, which has 6 at the end, then 224 has 4 at the end. And so they have 2, 4, 6, 8. And the non-examples, many a times the students, they understand better when we tell them not to do this, it registers in the mind better. I feel that because that age is such that when a learner is told, you don't have to do this, they will be extra careful, even if the concentration of the mind has gone somewhere else. The moment you say not to do this, the mind catches it faster. And so non-examples will give a better depth. So we have the ending with 5, or we have ending with 1, and so on. Let's come to the next one. So if the digital, if it's divisible by 3, if the digital sum, or you can say Yog Mulank, or the digital Mulank. Yog Mulank is 3. So that means the digital sum has to be here 2, 3, 4. When you add it up, 4, 3, 7 plus 2, 9. It's divisible by 3. 9 plus 3 is 12. Again, this is 12, divisible by 3. In this case, what is it? 15, again divisible by 3. But the moment it is not coming, the total divisible by 3, the number is not divisible by 3. These are things which we are regularly teaching our students, right? Fourth, it is divisible by 4 if the number formed by its last 2 digits is divisible by 4. So the things which we are teaching already, just a second. The things which we are already teaching, there I have written down the examples so that we can be a little quick also. Then if you notice 56, now we know 56 is divisible by 4. Then 28, 64, 52. So you just need to concentrate on the units and the tens place, and then check whether it is divisible by 4. It becomes an example divisible by 4. By 5, we are all aware it is 5 or 0. The children like it so much. Checking the divisibility with 5. Then it is divisible by 6. 6 is now having a factor 3 and 2. So if it is divisible by both of them, so that means the digital root should also become divisible by 3, and the units place must have 2, 4, 6, 8 or 0, right? Now in this case, I have taken examples 393. Now this is divisible by 3 because the total is divisible by 3. But the units place is not an even number. So it is not divisible by 6. Here the units place is 4. But if you total it up, 5 and 3, 8, and 2, 10, and 4, 14. So it is not divisible by 3. So it doesn't become divisible by 6. Right? Then I have written 7. Now at the moment we are not teaching this at the school level. Let's go further. 8. Maybe in the primary classes where you go to say 4th or 5th, there you are teaching this, that divisible by 8 if the number formed by its last 3 digits is divisible by 8. So here if you check out 872, well, it is very clearly divisible by 8. You can divide it. Then 648. So 8 is a 64, 0 and 1, right? And then we have here 32 divisible by 8 and so on, right? 36 is not divisible by this. I think there is a mistake here. 08 is divisible by 8. So this is not a non-example. Okay. The 9 one is rubbed off. Anyways, I'll write it down. It is divisible by 9. Just a second. Divisible by 9 if the digital ratio is 0. Right? 0, or it is a multiple of 9. You can say that also. So actually when the digital root comes out to be 9, we treat it as 0 also in Vedic mathematics. So kai baar hum in Vedic mathematics we just mentioned that the digital root is 0. It actually means that you come the answer comes as a multiple of 9 and we take it as 0. So very simply we can take it as something like this, a number which is this. So I have intentionally chosen a number where the sum comes out to be in pairs I have written, and I get the number which is divisible by 9. And you can proceed like that, 2, 7, 3, 6. Okay. So something like this. So very easy to create a number which is divisible by 9. Then we have this 10. Again, the most loved one and the earliest one to do the multiples of 10, 10, 20, 30. So it has the units place digit as 0. Nothing new in it. Now, 11. If its subtractive digital root or the Vyog Mulank is 0. So what we do is we actually take, put a bar here, and then it becomes adding those two and adding the other two and finding the difference. So I have 7 plus 4, 11, and 9 plus 2, 11 again. So it is coming out to be 0, right? And in this one, we put bars here. So 6 plus 4 is 10, and the other one is also 10. I'm getting 0. And it's not happening in this case because I have 8 and 3, 11, and 7 and 2 is 9. So I'm getting the answer 9. So the Vyog Mulank is 2 and not 0. So it is not divisible by 11. I move to if it is divisible, 12, if it is divisible by 4 and 3. So we check the digital root, sum should be multiple of 3, and the units and the tens place, that is that particular number tens and units को लेके 2-digit number at the end should be a multiple of 4, or you can say divisible by 4. Again, we are at a loss when we talk of 13. Then 14, again, it's a little challenging because it has the 7, which is again a prime number, and we don't know the divisibility by 7. 15, if it is divisible by 5 and 3. 16, I don't know if teachers are teaching this or it is in the curriculum. I don't think so. But I think for gifted students, we can be doing this, that if a number is divisible by 16, if the number formed by its last 4 digits is divisible by 16. Again, at the end, I have written 17. Again, we are unable to say anything about it. And for the 19 as well, we are not able to say anything. So let's move further. I'm coming to now the numbers which are ending with any of the digits 1, 3, 7, or 9. And I have written that they are mostly prime. I'm not saying they're always prime, they're mostly prime, or they have prime factors, only prime factors, okay? And let's take up a few examples. When I talk of course, here it was 7, which we were not able to do. Then we got stuck up at 13. We got stuck up at 17. Even 14 we got stuck up. But that I'm not taking right now, because once we know how to do 7, we'll be able to manage that also. Then 19, 21, 23, 27 is again a multiple, but still we can take it up. Okay, we can do oscillation with that also. Then 31, then 33, again 11 and 3 can be done, so let's forget about it. And then 37, 39, or if I go a little further, I may come across 61, I may come across 59, and so on. You know, the list is unending. And today's class, today's webinar, I'll be concentrating more on 2-digit. Of course, we'll be taking a few 3-digit also a little later if time permits. Of course, very interesting numbers also we'll talk of. So divisibility by these numbers, and I specifically feel that the classes maybe 4th, 5th, and the secondary classes, they will be very much interested in such knowledge where you have to, these divisibility by higher numbers. And so it will be, and plus the teachers also, they will be benefiting a lot, because we'll come across shorter methods, other than division. Oscillation or Veishtanam now. Veishtanam, here it is the process of checking divisibility. Just a second. It is zoomed. So positive oscillator follows the सूत्र. अब इसमें oscillation क्या होता है? उसमें covering होती है. And it is the process of checking divisibility. And it is found only for the divisor. So if we have positive oscillators, we follow the sutra ekadikene purven, that is one more than the previous. So if I have say 19, I make it increase it by 1, but the oscillator, the positive oscillator, is given the symbol P. So P becomes 2. Yani you forget the 0, and so that means you'll get the P as 2. So if we come across say 29, it will become 30, and so your P will be 3. If you have say 79, so it will become 80, and the P will become your 8. So that is the positive oscillator. We increase the number by 1, and we are getting, and obviously it is happening more with the 9 ending divisors. Now, एक न्यून पूर्वेन negative oscillator, इसमें subtraction involved होती है. We have subtraction over here, and so if I say 31, now the lower base is 30, lower sub base, right? So 1 less than that, and I forget about the 3 and we call it negative oscillator. So it is 3 bar. Yeah, hum 3 we can write 3 also, but we of course should remember that it is negative oscillator. And so in this case we'll be taking subtraction. In the positive oscillation we'll be taking up the process of addition. So if I have say 71, it will become 70, and so the Q will become 7 bar or the negative 7, right? So here I move further. I just looked at the time and I noticed that maybe I'm going a little slow. Now for a number ending with 3 or 7, so if we have 13, we have 17, what we do is we multiply it by 3 or 7 in order to make it 9 ending or 1 ending. So here 13 into 3. So the new modified divisor becomes 39. And for it, one more will become 40, and so P becomes 4. If I want to calculate the negative oscillator for 13, it will become 13 into 7, that is 91. And so the Q is 9. You can simply mention it 9 also without the bar, because Q itself means that it is a negative oscillator. Then 7, we can take it 49, P becomes 5. And if it is the negative oscillator, it becomes 2. Now, one very important thing that you have to note down here is that what is happening, that the sum of the positive oscillator and the negative oscillator is coming out to be the original divisor. So here P and Q add up to 7, here P and Q add up to 13, right? So I've taken a big example and a big number comparatively, 37. Now I know that 7 threes are, so 37 threes are, it becomes 111. And if I want to find out now one lesser, the Q becomes 11. Now I don't need to find out the positive oscillator by multiplication by 7. I simply subtract it from 11 and I get 26. So obviously 11 is better here to use than 26, because 26 is a bigger number, right? So that will be our discretion which oscillator we want to use. Now I'm coming straight to the questions. Now basically what is happening is that we will be in positive oscillation, we'll be adding the multiples of the divisor in a very quick method. And in the negative oscillation, we'll be subtracting the multiples of that number. Let's see how, I've chosen a very simple question here, and it says, is 76 divisible by 19? Now in this one, what we do is, we pick up, I'm just telling you the shortest method. 19, I write down 20, so my P is 2. So my P becomes as simple as 2. What am I to do? Keep on multiplying the 2 with the rightmost digit and add it to the rest of the number. So here it is 6, I multiply it with 2, 6 to the 12, and I add only this much, not the 6. So 7 plus 2, 9, and this is 1, and so it is divisible by 19, because the number that I have got is 19 here, and so yes, it is divisible by 19. Very interesting thing here is that actually what have I done? I have 76. If I tell you the logic, this is not to be done, but I am simply explaining you the logic. 76, I subtracted 6 and I added 120. And so it becomes 76 plus, how much have I added? 114. And this 114 is actually 19 times 6. So I have added a multiple of 19 to 76 to make it a bigger number so that it ends with a 0. And I am able to, and the rest of the number, I am able to say that it is divisible by 19. It comes as 19 or it comes as a multiple of 19, whereby I'll be able to say that it is divisible by 19. So this is the logic which is happening here at the moment. And if we have to do it in a line, although it is a very simple one. If we have to do it in a line, what we do is we have this, I write them a little separately, and I multiply this 6 with 12, and I get it here. 12 and add the 7, you get 19 here, and you say that yes, it is divisible. You'll understand it better in the next example. 1938. I've taken the same divisor so that you understand at once, and then we can move further. Now 1938, so my P is again 2. So 8 2s are 16, I'm adding 6 and 3 9, 19 and 1. Now 9 2s are 18, I add and I get 38. Okay, and now again I leave 8 2s are 16, I'm again getting 19. How to do it in a line? Very fast. 1 9 3 8. So what I do with this 8, I multiply 2 and add it to the next digit. So 8 2s are 16 plus 3 19. I write it here in the next line. Now I multiply the P, the oscillator, with 9. So 9 2s are 18 plus 1 19, 19 and 9 28. I again multiply the P by 2. 8 2s are 16 plus 2 18 and 1 19. I am again ending with a multiple of 19 or 19 itself. So yes, it is divisible. Very interesting feature is that I will be able to say the quotient also from here. How will I be able to say the quotient? Let's see. Now, if I consider this process, long process, now in this one, the digits that I have dropped, 8, 9, and 8. So if I calculate the complement of 898, the complement will become last from 10, 0 here, this one from 9, 102. This is nothing else but the quotient. You can check in your calculators and you can message, and Amit sir and Rajat sir can keep a track that are we getting this? Are we getting the quotient in your calculators?
Yeah, a lot of concerns are there. One of the educator is asking how P is 2. Can you please repeat the oscillator, the
Okay.
positive, negative? Once again, if for a few educators, you can quickly repeat that.
Okay. If the number is ending with 9, if the divisor is ending with 9, in that case, what you have to do is you raise that by 1. So that means ekadikain, yani increase 1 more than the previous. So 19 plus 1 becomes 20, and you forget about the 0, and so this 2 becomes the P, the positive oscillator. If you, for example, if you take 79, increase it by 1, it becomes 80, forget the 0. So 8 plus 1, 9 becomes the oscillator for the divisor 79. Same way, if you take say 49, you can divide by 49 also, although we know that it is not a prime number, but it is having factors 7 sevens are. So that means the only factors are prime over there, right? So for 49, increase it by 1, becomes 50, forget the 0, and now 5 becomes the positive oscillator or the P. Now in this, let me come back to this particular question. जो ये shorter method है, जो मैंने which I have given in one line. For that also, if you notice, I have multiplied the tick marked digits. There is 8 over here, there's 9 over here, there is 8 over here, and haven't we written this only here? So complement of 8, 9, 8 becomes the quotient, and that is 102. Isn't it amazing that We are able to write down the quotient, or rather, we have carried on the division. Now, the normal division we carry out from the right hand side, you know, the biggest, highermost place. Whereas here, actually, what we are doing is we are adding so that multiples of the divisor, so that using the oscillator, so that the last place keeps on becoming 0. So here you have actually subtracted, and we can analyze that at a particular later stage. But let me take more examples so that you feel more comfortable. Okay, 2739. So 29. So your P is one more 30. Forget the 0. 3 aa gaya. Now 3 nines are 27. 7 and 3 10. 0. Carry 1. Again this 3. Now you keep on doing this. So 3 zeros is 0. You add, although it doesn't require here. But till the digits are there, 3 zeros 0. You have added. You're getting 3. Now this 3 is not divisible by 29. So this number is not divisible by 29. I hope it is clear to everyone. Now here the next one. I think you can not switch on the mic, but we can simply check it on the chat, because if you have understood it, you can give
Ma'am,
whatever your
please slow.
emojis.
Ma'am, please be slow. There's a message they are coming. Yeah. So
I have
we
lots to
did
share. Then
number.
normally in my classes I take 1.5 sessions for divisibility, but Amit sir said 1.5 hours, so I said okay, I'll try to pitch in more. In that case, negative oscillations बच जाएगा. यहाँ पे दोबारा करूँ? Okay, you want me to do it with the shortest method? Let me do it. 2739. So what we do is we multiply this 9 with 3. So I am writing down the rough work here. 9 into 3, because P is 3. And I am adding the next digit, the tens place digit. So it is 3. 9 3 is 27 plus 3 becomes 30. Now I am multiplying the P with 0. That is this number. And then adding the next digit, 7. So it becomes 0 plus 7, right? 7 here. And then the next is for this 7, 7 threes are 21 plus 2, the next digit becomes 23, and 23 is not divisible by 29. Hence, I'm not getting the divisibility for this particular number. A bigger.
Ma'am, I have given one question to them in a chat box. Question for them is, using the oscillator rule, check if the number 6174, which is actually the code for our certification also,
It is divisible by 7
or not.
Check
That
the divisibility.
let them check. Let you
Okay.
please give them 2 minutes to check
I
this
have
out.
taken the 10th question for that.
Okay, okay.
I'll bring it up.
Yeah.
9th. Where is the 10th? Okay, I've skipped it.
So let them also try.
I'll write it down.
Yeah, the recording will be made available. (6174) is a Karp-Raker constant, and which is the password, the code to get your certification. The feedback form will be shared at the end of the webinar. Therein, there will be a one question where you need to input this number 6174. So remember this number to get your certificate also, and please check it out. Try it out by your own, then ma'am will explain. So, ma'am, we are getting a lot of responses. Yes, Komal ji is saying, Vishal ji, Vidya ji is saying yes, Ramanpreet, Asha ji, and I'm assuming you are not going with the usual multiplication, normal usual division actually. Yeah, Sonia ji, Mahima ji, yeah, Ira ji, Mukta ji, lot of educators, they are saying yes. So we assume that they are actually getting what you are teaching. That's great, ma'am. Okay, that's great. Oscillator method only you are using, Ramanjit. Okay, that's Komalji. Okay, Tusharji is saying, can you please repeat this? So ma'am will explain that. Okay, Harshji, Dineshji, Jyotiji. Okay, that's great. So ma'am, that's great. You are a good teacher and we all are a good learner.
Thank you, thank you. So here I'll talk about the solution for this particular
Yeah,
one, and you can
please.
cross check. So here 7 is the number. Now 7 is, of course, is not ending with 9. So I have to make it a number where 9 comes into picture. So it is 49. And now 1 more than 49 is 50. So P for 7 is 5, right? And so if I calculate this, if I can we do it by just direct? Let's do it. So step 1 will become, I'll write down the steps and you'll be doing in a line. Now the P5 into the first digit 4, that is this one, plus 7. So 5 was a 20 plus 7, 27. I write down 27 here. Now in the second step, we pick up 5, that is the P, into 7, plus 2, which is besides it, plus 1, the next digit, right? So 5 7 is 35, plus 3, 38. I now come to 8. So the third step is 8 into 5. So that means my P into 8 plus 3 plus 6. Let's check up. 8 5s are 40 plus 9. I'm getting 49. So yes, it is divisible by 49. And so if the number is divisible by 49, it is divisible by 7, right? So yes to ho gaya divisibility ka. Now I'm coming to the quotient part. That is important. Now the quotient for 49, it will become the complement of which number? The tick marked ones, not the 49. 874. So that means it is equal to, now I am calculating all from 9, 126. But this is for 49. And how do I get 49? By multiplying 7 with it. So the quotient for 7 will come out if I multiply this 126 by 7. So 7 6 are 42, carry 4 here, 7 2s are 14 and 4 18, 8 carry 1, and this is this. So this becomes the quotient when I divide the Kapreka number by 7. And Kapreka number is the code for your certification to get the certificates, as Amit sir has already told you. I hope it is clear, and because this thing, getting the quotient, I have read many books, but it is very rare that it tells you about the quotient. But again, as I said, that the quotient can be found only if you get a multiple of that number and divisibility ho jayegi. But when we talk of the negative oscillation, I think because the time is a little short, so all the questions that I had taken up, 13, again you will multiply by 3 and you will get it. So I'll move to the negative oscillation so that you can have some idea about that. Okay. So negative oscillators. Now again, I have no time for the vincular numbers or the Mishrank. Now basically this Mishrank is used to do the question in a one line, as I am doing it here in this case. Right. So negative oscillation ke liye, right now I'll tell you the long method, and in some other time I can guide you with the this shortcut also, because explanation of vinculum will again take 5-7 minutes, at least 10 minutes, and then later on explaining it for the process of oscillation will take time. So I am just taking the long method for you, but again that is also not so long. Now here we get the number 31. I'm now going to negative oscillation. So 31. So instead of ekadikain, it is ekanun. Noon in Hindi means lesser. So that means one lesser than the previous. So 31 say one lesser we take, and now we get rid of the 0 and I get the 3, but I call it bar and I call it Q. Or you can simply say Q as 3. For this purpose, we need Q as 3. For the shorter in one line calculation, we need the bar actually for this. Let me now take the number 8, 1, 5, 3. So what I do is again similar. The only thing is I have to subtract now. So Q is 3. I multiply it with the first digit. 3 3s are 9 and I subtract. Okay. Again I take 6 and multiply it with 3. 6 3s are 18 and I subtract again. Now here it is 7, or it will be 6, sorry. Right? Now I take this 2 and now I get 3 2s are 6. I get 0. Now here in this case, what has happened is that we have multiplied, we have taken the multiples of 31 and we have subtracted them from the original number. Now because we have subtracted, what is happening is we are reducing the number gradually, so that the end, ये देखो यहाँ पर इस step में actually number क्या reduce हो गया? It became 8060 actually. In reality, it is becoming this, right? Then further, when I reduce, it becomes 620 and so on. And so eventually, if you get in the end 0, it means it is divisible by 31 because you're subtracting multiples of 31. And if in case you don't get 0, it means that it's not divisible, right? And now the quotient, the most interesting part that I love to do it without, just doing subtraction and addition, and you are able to say that you are carry out the division. So the quotient here is this digit 2, then 6, then this 3 as it is. No complement. In the positive oscillation, we took the complement because we were adding. So base banane ke liye, for making the base, whatever the number was required later on, that was added. Those were the multiples of 19 that we got the quotient, And so for the number which was earlier there, we had to take the complement. Whereas here we are subtracting. So we are actually reducing that number. So the quotient is 263, where we get it directly. In case of doing it in those who already know what a vinculum is, for them, we say that we have this and we take it as alternate, we take them as negative numbers. वहाँ मिश्रांक होता है. In Vedic mathematics, we have numbers which are not purely positive or which are not purely negative. We may come across numbers which are, say, like this. So it actually means 200 minus 90 plus 3. And so on. So that concept is there. So वो 3 उसमें Q को आपको 3 बार लेना पड़ेगा, and you multiply in every step. You do the same. 3 bar into 3 makes it bar 9. Whatever is negative subtract होगा, जिसके ऊपर bar नहीं, the one which doesn't have a bar, that will be added. So the first step will become 3 bar into 3, that is bar 9. From that subtract minus 5, so plus 5 हो गया. So minus 9 plus 5 makes it bar 4. Then 4 3s are 12. It becomes positive. 12 plus 1, 13. And then 3 bar into 3, bar 9. Bar 9 plus 1 becomes bar 8. And bar 8 में से bar 8 subtract करेंगे, you'll get 0. And so it becomes this. And the number which is forming the quotient, उसके लिए मुझे vinculum conversion चाहिए, वो आपको आना चाहिए. So in this case, the quotient actually is 3 4 bar 3. So if you want to calculate it otherwise, it becomes 300 minus 40 plus 3. And you can compute, and it comes out to be the same as 263. I hope it is not much of a problem. For the others, I think for the new members, Jinko Velkulam, who absolutely don't have any idea about Vedic maths or Bharatiya Ganit, they might face some
Yeah,
problem.
few educators are sending that emoji that they are not able to understand, but
Yes,
few are
this
getting it.
part they are not able
Yeah,
to follow probably
yeah.
because it includes multiplication of negative numbers into positive numbers. And even for the students, once they talk of negative numbers and their multiplication and that algebra is done thoroughly with them, only then they will be able to follow this. So that's what I'm saying. It's a gradual effort. I have just tried I have tried to cater to
We
those
can
also
actually
who.
plan one another session specifically for this topic, ma'am. We can do
Okay,
that.
okay, we can do that. I
Yeah.
can take as many examples. Now I'm coming to some interesting questions. I'm forgetting. ये देखो 41 का करना है करें कितना time है 12:09. Do I
Yeah,
have
yeah, ma'am.
7 minutes, 10
Yeah,
minutes?
yeah, ma'am. Please continue.
Okay, चलिए. I'll take on this 23288. By 41. Now 41 divisor है, so again it becomes 40, and so your Q becomes 4. Right? The negative oscillator. So you keep on multiplying by 4 and subtracting. So 4 is a 32. 6 here out of 12, 9, 2. Then 6 fours are 24. 5 fours are 20. And I'm getting so conveniently the 0. And now let me just check out the numbers which will form the quotient. Like a student, I feel the best part about this is this, that my quotient comes out to be 568. Right? So it is divisible by 41 and we get the quotient. This much is clear. One liner छोड़ देते हैं. One liner के लिए next एक session ले लेंगे. ठीक है?
Yeah, sure, ma'am.
ठीक है?
मैम आप क्वेश्चन दे दो सबको करने के लिए एक दो.
हाँ,
We will
ये
wait for
लीजिए.
them. Yeah,
ये
let them
लीजिए.
try this question.
So 17 they'll do. 17 into 3 करेंगे. I'll just help out
Chat is
with the
open. Let them
divisor.
try. Chat is open.
Okay. For 17, you can all try this. Obviously, 17 into 7 will be a bigger number. So let's take up a smaller number. 17 into 3 is 51. And so your Q, taking your Q as 5. So please check out what are you getting the divisibility, whether it is divisible or not. And also let me know whether it is if it is, what is the quotient that you're getting.
So we are waiting for 2 minutes.
Yes,
Please everyone
yeah.
try this out. And think, is it a positive or negative oscillator? That is the first thing, very important observation.
Exactly, which is being helpful.
Oh, we are getting the answer. Tarang ji saying divisible. Vidya ji, yes, divisible. Mamta ji is saying no. Jyoti ji divisible कह रहे हैं, and others are also writing yes,
A
empty.
very
Okay.
interesting question that I have chosen to give them.
Nisha ji saying it's a negative oscillator.
Acha.
Negative, great. Priya Pearl ji, yes,
Are you
yes.
getting the 0? Check out in the end.
Satish ji saying no, Indu ji saying yes. So it means there is a mixed variety. So we need to
So they
check
are
that out.
getting,
Negative 17 is left. Priyanka Khanna ji is saying
yes,
negative
negative
17 is
17.
left.
Nice, good.
Maria ji saying yes. KK
So
Jha
you
sir कह रहे हैं
understood?
no. Okay. So I think मैम अभी अब chat पढ़ रहे होंगे साथ में second device से.
Yeah, yeah.
Yeah. So math teachers के साथ ये important है, जब तक उनको involve नहीं करोगे ना पता नहीं चलेगा.
सही बात है.
Yeah, Rajveer
Okay.
ji again saying negative 17. We are getting
Now, but
now.
in this case, the problem is, I'll explain. Now you are getting in the end,
Yeah.
most of you are getting not 0, but you are getting minus 17. Right? Now, if we don't get 0, that means that what have we done? In the process, we have gone beyond 0. We have gone beyond 0, and so we are not able to write the quotient in such a case. So this is what I have written here. The quotient cannot be found using oscillation in this case. So negative oscillation may we have to take care. In the positive, what happens is that you get a divisor itself, or you get a multiple of the divisor. And so divisibility happens. And so what happens is that you are able to say the quotient. Whereas in this case, if you don't get a 0 in the end, it means you cannot replace division here in this process, in this particular example, and so you cannot say anything about the quotient. I hope I have equipped all of you that what are the cases when we can find out the quotient in case of negative oscillation and when we cannot.
Ma'am, कह रही है मैम कौन कह रहा था प्रीति जी saying can you please show the whole working for this question
Okay, I'll show you the working.
starting with the beginning. Yeah, please.
Right, sure.
So what is the final answer? Abhaji is saying, so what is the, is it really divisible?
Final answer is it is divisible. It is divisible
Yeah.
because we are getting the number 17 over there.
Yeah,
right?
Okay, yeah. Please, but do share the solution.
Yeah. 6256. So I have to take the Q5 and keep on multiplying and subtracting. So 6 here into 5. 6 5s are 30. I subtract out of 625. And what do I get? I get 595. Fine. Now, again 5 5s are 25. I still have to carry on because this 4 is coming as a digit from there. 5 4s are 20 and I'm subtracting. Now see, it is 3 minus 20 and so the answer here is minus 17. Now minus 17 is divisible by 17. So yes, divisibility is there, right? It is divisible. But as I said, we cannot find the quotient in such a case. I hope things are clear.
How to find positive or negative oscillator to use? Someone is missing that. I think the main
Now what
part.
happens is, okay, I'll explain that a little.
Yeah.
देखिए, positive oscillator. Quickly coming to that. Now, if the number is ending with say 9, so you say you have 69. Now you increase it by 1. Okay, becomes 70. Forget the 0, and so your positive oscillator. Why positive? You have added, right? More than the divisor you are taking. So it is positive oscillator. And in the case of positive oscillator, you keep on multiplying with the rightmost digit with the oscillator and adding it to the rest of the number. Till the end, they all are used up. All the digits are used up of the number of the dividend. And in the end, if you get a multiple of the, say, 69, right, then it is divisible by 69. If you take, say, 99, I am actually going to take this further. So, agar 100 lete ho, so you can take. Now here actually, I'll tell you a process where you can get rid of both the zeros. So, agar P lena hai, to P 10 bhi le sakte ho, right? Magar isse better, shorter method I will tell you later on. If you have, say, 39 again is 13 into 3, so you can take it up. So it becomes 40 ka 0, you forget the 0, and the P becomes 4. Now, if you talk of the negative oscillators, what happens is that you come across 31, you come across 41, 71, 81. Now, so for 31, the Q becomes 3. Normally we say 3 bar, okay, negative 3. Then 41 ke liye negative 3 bar here, 4 bar here, 7 bar here, 8 bar here, and so on. So that is your negative oscillators. In case of negative oscillation, you have to repeat the process, but instead of addition, you have to subtract. Keep on subtracting till you get to 0 or again a multiple of the divisor. In case you get a 0, you are able to write down the quotient. In case you don't get a 0 but a multiple, divisibility occurs, but you don't get the quotient, right? Now, as I said, again, I have taken 17. So if a number is ending with 17 or say, sorry, 7 or 3 or so on, so you can convert. See, 7 into 3 makes it 51. So your Q becomes 5. The 51 changes to 50, 1 lesser. And so your Q becomes, the negative oscillator becomes this. Now, if the negative oscillator is 5, as I told that the sum of the positive and the negative oscillator is the divisor itself. So if Q is 5, then in this case, the P is going to become 17 minus 5. How much? 12. Obviously, multiplication with 12 is more tedious, more difficult than 5. So here, using negative oscillation will be a better idea than the positive oscillation, right? So this is how we decide that positive or negative we have to pick up. Now, 21. So Q is 2. You can note down the questions or rather just sit with a calculator 21 times anything and then start doing the oscillation.
Is this rule applicable only for the divisibility for prime numbers or even for numbers, say, if any other number is there? Then even that rule is workable for composite number?
See, I think when you have any even number ending other than 1379, many a times it becomes difficult to convert it to 9 ending or 1 ending.
Yeah. So in that
So
case,
that's
it
the
is
logic.
applicable only for the prime number, which again, I also feel
That
the
is
same.
the logic.
Yeah.
That is the
Shweta ji is
logic
saying,
because,
my dad taught me this rule.
oh, good.
Okay.
Good,
Preeti
good.
ji is saying, hats off to your patient, ma'am, for explaining this. And of course, okay. Yeah, that's
See,
great.
I
Yeah.
tackle most of the times applications of Vedic mathematics in modern mathematics. So mostly I carry out chapters of trigonometry, coordinate geometry, and so on. So as far as the calculation part is concerned, of course I know it, I have done it. But my forte is application. But these are simple things, and yet they involve around logics, and those logics, unless they are explained to the faculty, it doesn't make sense. And even through all of you, I am also learning, as Amit sir just now said that why not other numbers. I never thought about it, why other numbers, because मुझे लगा कि उनकी तो divisibility, their divisibility is
Okay.
possible,
Yeah.
so why bother? But yes, you are right. It made me learn and say that yes, in that case, 1 or 9. As I was speaking, I was getting it, so that's the measure of experience. Anyways, thanks to God for giving me that experience. Anyways, and to all of you also, because through learning and sharing, we learn from each other. So here, I have tried to explain somehow कि ये 1743. If you want to take a click of this, just take a click of this question. Is 1743 divisible by 21? And then if you take a click of the logic, you will be better equipped later on. Okay, actually, what are we doing? The logic of successive subtraction. So you can think upon it, contemplate on it a little later. And is it visible? Yeah. So for this particular question, I've tried to explain the thing. आप पहले इसको you carry it on, try to do the question, and then see that according to modern mathematics, like whatever we teach the students, this is the logic that we are subtracting 21 times. We are subtracting. Your divisibility by 21 tha, so we are subtracting 21 into 3. We are subtracting 21 into 8, and we are reaching the 0. So that is the process that is going on, right? Okay. So I am now group oscillation. This is a very interesting concept. Now here I have a big number and I'm saying divisibility by 99. So I'll take up an example. Now here higher oscillation numbers. Till now whatever we said, oscillators P and Q, they were first order P and Q. positive oscillator and it's a negative oscillator. The moment you increase the number of zeros, to avoid, it becomes a second order. So jab 99, so 99, I get the one higher number as 100. But if I get rid of 0 and 1, both of them, my P, but I don't call it P anymore, it is now second order positive oscillator, it becomes 1. So P2 is 1, and I'll repeat the process with this. Just check out what I do. So I'll multiply this 1 with 3, add it to the next number, 6. Multiply again 6 by, ye jo hai multiplication, it will give the digit itself. So basically it will end up adding the digits, 3 into 1 plus 3 gives me 6, then 6 into 1 plus 1 gives me 7, then 7 plus 5, 12, 12 plus 5, 17, 17 plus 1, 18, right? Just a second. I think it should be visible. I must have committed some error. Oh, sorry. I have to take groups. I'm written grouping and I have not taken groups. That's the fact. That error has happened. Excuse me. Now, as I'm saying grouping, we have got rid of 2 zeros. So I'll group this number in twos, in 2 digits. So what I do is, I take this whole 33, multiply it with the P2, that is 1, and add it to the next one, next group. So I get 3 plus 1, 4, 5 plus 3, 8. And now again, this 84, I multiply it with 1, that is 184 only, and add it to the next one. And what do I get? 99. 99 is divisible by 99. So yes, the divisibility occurs. Not only that, the quotient is the complement of 8433. So in a way, it becomes all from 9. That is 1, 5, 6, 7. Ye quotient aayega. So actually, what have you done? You have made them into groups of 2 pairs banake, and you are simply adding. So you can say it is a shortcut for 99. But actually, the process that has happened is oscillation. So in the market, in the
Nidhi ji,
everywhere,
I'm sorry. Nidhi ma'am saying, can't we do this by checking for 11 and 9 both?
of course, we can do that.
Yeah, that can be done.
Of course, we can do that. 11 and 9, we have those methods. But you just notice what I have done. I have taken this as a group, added it to this, added it to this. Why? Because my P2, the positive oscillator, is 1. So every time I multiply the group of 2 digits with 1, wo wahi rahega. So addition of the pair of digits, starting from, of course, the rightmost, that is the units place. And aapne simply, you've added and you get a number which is 99, divisible by 99. And not only that, you get the quotient also. Ab isi ko, the same thing is given as shorts, as a magic, Vedic maths ka, and whatnot, It's not a magic. It's a proper reason, logic, why we are doing it. It is involving that. So I actually get very annoyed when people say that Vedic mathematics is a magic. No, it's not a magic. It involves proper logic and mathematics calculation. You don't have to memorize. हाँ, याद रख सकते हो. अगर पता चल गया कि oscillation process है 99 के केस में, ये कर सकते हैं. Now if you notice by 999, so 999 का one more होगा 1000, and so in this case your P3 will become 1. Now, the moment you say the third order positive oscillator, you have to take it groups of 3. So 123, then 334, and then 542. And now, because aapka oscillator 1 hai, so you simply have to add the digits, all of them together. So let me add them. 542, added kar diya. 6 here, 7, 8. And to this I add 123, So what do I get? 9, 9 and 9 again. So I'm getting this. So this is what you get, right? And so it is divisible. Yes, it is divisible. And the quotient will be the complement of 8, 7, 6, ye wala group and ye wala group, 5, 4, 2. So you can, if you want to use it as a magic, you can. Okay, this number when divided by 999, I can tell the quotient. Of course, जो last के दो groups हैं, पहले बिल्कुल लास्ट वाले तीन ग्रुप्स को, तीन डिजिट्स को छोड़ के, and if you distribute them and uska complement लिख, you write down the complement and you've done it. So that is, it is 1 here, 2 here, 3 here, 4, 5, and the last one is out of 10, so it is 8. So the question is 1, 2, 3, 4, 5, 8. Interesting. I'm not seeing any thumbs up.
Yeah, that's a real motivations. And since the time is already over, so thank you, ma'am. And
okay,
yeah, thumbs
this
up.
special divisor I'll take it up later. Then it is again very interesting, but इसमें क्यों
Teachers
आ
are
जाता है?
saying they need more sessions actually. Yes, so ma'am is an expert on this. Definitely will request her to hold such webinars, such sessions in detail, in brief and in detail. Maybe it can be bifurcated to 3, 4, 5 sessions for all those who are interested. So that's really great. Ji. So Rahul sir, Rahul Sofat sir,
Should I stop
are you
sharing?
here? Over to you. Yeah, ma'am, please. Rahul sir, Rahul Sofat sir, you are the meeting host.
Yeah. Hello.
Yeah, you are audible, sir.
Yeah. Good afternoon, all. It was really an insightful webinar. And first of all, I would like to thank Roman Dhawan ma'am for the wonderful session she took today. Ma'am enlightened us with one of the many hidden math concepts that Bharatiya Ganit, the so-called Indian knowledge system, offers. And the way Roman ma'am explained divisibility by prime numbers with simultaneously obtaining the quotient is new and fascinating. It was heartening to know about the application of all these processes and methods in computers, cryptography, extra. And these methods are not only known in India, but gaining popularity in other countries as well, with some reference to their application in NASA. And I extend my gratitude to all the members of the executive committee, especially to VP Gupta sir, Shri S.N. Chibbar sir, Nijhavan sir, for their continuous guidance and support. And special thanks to all the members and all our teachers, the mathematics fraternity, educators, researchers, for their presence and displaying commitment and passion for the subject. And finally, I hope all the teachers here are members of the DAMT. In case you are not, the link is provided in the chat. Any suggestion from the teachers are welcome. You can suggest topics for our next webinar. And in case you want to be the resource person for conducting any of these webinars, you are welcome. You can contact DAMT, and your articles for the newsletter will be appreciated. And finally, many thanks to Anita Sharma ma'am for her support, and special applaud to Mr. Amit Bajaj and Mr. Rohit Upadhyay for conducting this webinar, creating social media handles and the website. And finally, I would like to say, keep yourself updated, stay connected. The mail ID is provided, or through any other social media handles which have been discussed. And that's all. You are our support system. Keep this DMT live and kicking. And that's all from my side. Thank you all.
Yeah, thank you, Rahul.
Thank you so
Thank you
much.
very much. Thank
Thank
you,
you.
Roman ma'am, all the executive members who are able to join today some of them are not able to join, but I know they are good wishes and their blessings are always with us. I'm
Thank you.
ending the
Thank
recording.
you to
Yeah.
Amit sir in particular.
Yeah,
He's
thank
helped me a lot in arranging, and because with the technology, I obviously needed much more help, And he's always, just a call away, and that's so nice of him. And I'm thankful to DAMT whole executive committee for giving me this chance, and all of you esteemed friends who have taken out time to learn something new. I think that life is very small, and we should all keep on learning new things always. Keep up the learning. All the best to
Yeah.
everyone.
Thank you, ma'am. Thank you so much.
Thank you. Thank you so much.